All right, so in our unit circle lesson, we talked about which trig functions are positive and negative in which quadrant. So I'm just going to write this down. Here is a really nice trick. You're just going to remember this phrase, that all students take calculus. Okay, and this will help you. This all goes right here. So all students in quadrant 2 take quadrant 3, and then calculus in quadrant 4. So this is just going to tell you which trig functions are positive in these quadrants. So quadrant 1, they're all positive. So we're going to say that the sine is positive, the cosine is positive, and the tangent. All three of those are positive, and the reciprocals are positive in quadrant 1. Okay, quadrant 2, notice students starts with an S, so does sine. So the sine and its reciprocal, the cosecant, are the only trig functions that are positive in quadrant 2. Quadrant 3, only the t or the tangent is positive. So the sine and the cosine are negative in quadrant 3. Only the tangent is positive. And quadrant 4, purple, calculus. So we've got our cosine is positive in quadrant 4. The tangent and the sine are negative. Okay, so all students take calculus. Remember, just counterclockwise, all students take calculus. All right, so in your homework and on the quiz, you're going to actually use this to help us to decide which quadrant our terminal side of theta could be in. Sometimes there's more than one. Sometimes it could be in quadrant. By the way, we might want to label these. This is quadrant 1, quadrant 2. They usually use Roman numerals. I'm okay if you use just numbers too. 1, 2, 3, and 4. Those are how we label our quadrants. Quadrant 1, 2, 3, 4. Okay, so we know, look at this lovely problem, that the tangent is greater than 0. So sometimes I just like to say if it's greater than 0, that means it's positive. Okay, so the tangent is positive. Which quadrants could the terminal side of theta lie? So you just look up here and say, oh, they're all positive in quadrant 1. So it could be quadrant 1, or they're all positive, or the tangent is also positive in quadrant 3. I'm just going to write normal numbers, but no, you can use the Roman numerals if you'd like. Say, okay, so 2 quadrants, if I know that my tangent's positive, I know my angle's either in quadrant 3 or quadrant 1, because in 2 and 4, that's tangent is negative. All right, look at this next one. It's the secant this time. Now, remember the secant. I just remember the secant is the reciprocal. If it starts with an S, it's the reciprocal of the one that starts with a C. So it matches up with the cosine. So I could say, in fact, this problem could just say the cosine of theta is less than 0. Okay, so if you don't want to work with the secant, change it to the cosine. Just always change the letter. So if it's S, it's a C. If it's a C, a cosecant, then it goes to the sine. All right, and again, I like to just remind myself it's less than 0, so that means it's negative. We want to know where the cosine is negative is what they're asking. So in quadrant 1, they're all positive. It's not negative. But in quadrant 2, only the sine is positive. That means that the cosine is negative there in quadrant 2. Or in quadrant 3, notice that the tangent is the only one that's positive. So quadrant 3, it could be is where the cosine's negative as well. Okay, quadrant 4, the cosine's positive. Quadrant 1, the cosine's positive. So can't be those 2 quadrants, but quadrant 2 or quadrant 3 are both fantastic answers. Okay, we're going to scroll down here a little bit more. So I'm just going to draw my little thing here and write my all students take calculus right here so I remember. All right, oops, I think I messed this problem up. All right, so if the sine is greater than 0, so again, greater than 0, that means positive. What quadrant could it be in? So again, all of them are positive in quadrant 1. So it could be quadrant 1, or the sine is also positive in quadrant 2 right there. Okay, sine is negative because it's your y values. The sine is your y values. They're negative down here in those 2 quadrants. All right. This one has two stipulations. So usually when it gives you two stipulations, it's going to narrow it down just to one quadrant. Yeah, let's circle that answer. All right, so let's look right here at this one. It says the cosine is less than 0. So the cosine is negative there. And the cotangent, remember as well, the cotangent is the reciprocal of the tangent. So we're going to say the tangent is greater than 0 or positive. So we're looking, let's first of all look at where the cosine is negative. So we know that the cosine is positive right here. They're all positive here, and they're all positive here. That means that the cosine is going to be negative in these two quadrants. So in quadrant 2 or quadrant 3, the cosine is negative. Now don't circle that answer because one of them will be eliminated here when we look at this next stipulation. It also wants us to tell them where the tangent is greater than 0 or where the tangent is positive, only out of those two. Okay, so we look up here in quadrant 2, the sine is what's positive, not the tangent. So it's not going to be quadrant 2, but quadrant 3, notice that that tangent is positive. So that's the one you want to circle. Quadrant 3, the cosine's negative and the tangent is positive, both of them. All right, look at this last one in this unit. Then we'll save our reference angles till the very end. But we're going to find the sine. Now this goes back to last unit as well, but they're basically going to tell us where to draw our lovely triangle. So notice right here, when we drew our unit circle, you might want to have your unit circle still out. If we're looking at radians, here's our 0, here's our pi halves radians, here's pi radians, here's 3 pi over 2 radians, and this was 2 pi all the way around. So when they're telling me my angle here, my angle is greater than this 3 pi halves. So it's bigger than this all the way to there, but it's less than 2 pi. So it's somewhere here in quadrant 4. Okay, in fact, you could just kind of draw. Mine won't be to scale, but here is a nice, lovely triangle drawn in quadrant 4. So that's what this tells me, is that my triangle is in quadrant 4. Okay. Other than that, it's going to tell me a little bit about the sines. Notice that the cosine is positive in quadrant 4, and they gave me the cosine. It was positive. However, my tangent and my sine, they're asking for the sine, are both negative. So I'm going to have a negative number, kind of keep that in mind. But all we're going to do, just like last unit, oh, I want purple, is we're going to label. So we know that the cosine, before we even label, let's remember our SOHCAHTOA. SOHCAHTOA, so they've told me my cosine. So they've told me the cos. They've said that the cosine is this. Remember, the cosine is the adjacent. So this 12 is my adjacent side over the hypotenuse. So they've given me two of my sides of my triangle. So if I were to label this, and remember, theta always is the one at the origin. So my adjacent side here is 12. The hypotenuse is across from your right angle. This is 13. So first of all, we need to find our opposite side because the sine uses the opposite side. So we're going to use our a squared plus b squared is equal to c squared. All right, so when we're plugging this in, c has to be our hypotenuse. That is our 13 right here. But a and b can mix up. Let's just do 12 squared plus b squared. So we got 144, that's 12 squared, plus b squared is equal to 169 is that 13 squared. Okay, so subtract our 144, we're going to solve for that b squared, and that means that b squared is equal to 25, which means when I undo that square, when I take the square root, the square root of b squared is b is equal to 5. Now, notice this side of this triangle is 5, but because it's in quadrant 4, remember in quadrant 4, our y values are negative. So I'm going to write, whoops, it's going to disappear. I'm going to write a negative by that 5 right there to remind me that my sine is going to be a negative number. So you want, because that y value goes down, this point is over 12 down 5, that my sine is going to be negative in quadrant 4. So then we just fill in our our lovely SOHCAHTOA. So the sine is equal to the opposite. Just make sure, so we didn't label this. That here's theta, so this is my opposite. Here's my adjacent. Here's my hypotenuse. So the sine is equal to the opposite, or -5, over the hypotenuse, or 13. And that's how we find our sine right there. Pretty nifty. All right, stay tuned for the last video